Right. Hello, grade 12s. Welcome to EduBlush Visual Academy. Today we are on lesson 4 under functions and graphs. A very simple section. A very simple section. Just in lesson 3, we're looking at we defined what a function is. We discovered that there are two types of functions: a one-to-one function and a many-to-one function. We defined a one-to-one function as a function where one element of the domain is associated with a unique element of the range. And a many-to-one function is where many elements of the domain is associated with a unique element of the range, right? That was the previous lesson under functions. Okay, now I want us to move to the next aspect, which is determining what we call the inverse of a function. The inverse of a function. Okay, let me take you to the board. Inverse of a function. Right, let's look at the inverse of a function. What is an inverse? What is an inverse? Probably this will come and this will cross your mind. What's an inverse? We are talking about an inverse of a function. What is it? Right. Now, inverse simply means the reverse, like the inverse of giving is taking. The reverse process of addition is subtraction. So when we're looking at inverse processes in the lower grade, we're talking about inverse of multiplication is division, that of division is multiplication, inverse of a square root is the square, that of a square is the square root, inverse of a cube root is the cube, that of a cube is the square root, right? So an inverse, it is the reverse or the opposite process. Okay, right. Now, let's look at these functions. And graphs. Functions and what? And graphs. Okay, I'm looking basically on the inverse of a function. The inverse of a function. Okay, right. Now, inverse, word inverse means basically it means what? The reverse or opposite process. The reverse or the opposite process. Right, that's an inverse of a function. Okay, right. Now, defining it classically, or the classical definition of the inverse of a function, or a mathematical definition, will say if f of x is the inverse of g of x, then f right. Now, if f is the inverse of g, then g nested into f of x should give us what? X. A nested or a composite function, it is when you place one function into another function. Where there is x in f of x, I'm going to plug the whole of g of x. Then simplify. And if I simplify, and get my answer as x, then it means f is an inverse of what? Of g, or the other way around. You can also nest f inside g, means say this would be g f of x nested inside. If you simplify, then you get what? Your x. This is a mathematical definition of the inverse of a function. And when you are asked to show, or when you're asked to prove that f is the inverse of g or the other way around, you just nest one function into the other, or you place wherever there's x, you put g of x or f of x, whichever the case might be. If the answer simplifies to x, then you can conclude that this f is an inverse of what? Of g. Okay, I'll give you an illustration as we'll be developing this lesson. Now, the next thing that I'm supposed to highlight is the symbol, right? The symbols that you are going to use under this section. The inverse of a function, f inverse, or the inverse of f of x, something like that. We read that as the inverse of f of x, not f to the power of -1, but the inverse of what? F of x. So this is read as the inverse of f of x. Okay, or it can be presented as f inverse like that, which can also be read as f the inverse of f in short, or they can just say, you can just read it as f inverse, something like that. Okay, you can just read it as just f inverse. Right, now determining the inverse of a function, determining the inverse of a function. Right, now determining the inverse of a function, any function, the inverse of a function is deduced in two ways. You can do it algebraically, or you can do it graphically. Right, the inverse, determine the inverse of a function. Right, the inverse of a function. There are two methods. The first one, it is the algebraic method. The second one, it is the graphical method. So at this stage, one should be able to deduce the inverse of a function graphically and also algebraically. Deducing the inverse either algebraically and graphically. Okay, right. I'm going to start with determining the inverse algebraically. Determining the inverse of a function algebraically. Okay, determining the inverse of a function algebraically. Okay, now for me to come up with the inverse of a function algebraically, I'm going to say, let me do an illustration there that will take us through the process of getting the inverse algebraically. Say I've got a function. Say I'm given a function f of x, given f of x to be equal to 2x minus a 1. 2x minus a 1. Determine the inverse of f of x. Right. Now, if you look at your f of x, there are two parameters that are affecting x. There is 2 and there is minus 1. So I'll come and say my f of x is equal to 2x minus 1. Right. Now, if you look at this function, you can see that there are two parameters affecting your x. The first one is 2. The other one is what? Minus 1. Right. Where there is x, 2 is multiplying. Where there is x, 1 is subtracting. Now I'm supposed to take the inverse process. I'm supposed to take the reverse way. I know that the inverse of subtraction is addition. The inverse of multiplication is what? Division. So if I'm given an expression like this, I'm going to say f inverse is going to be equal to, where there is x, I'm going to work from the right-hand side going back to the to the left-hand side. Meaning to say, I'm going to look at the reverse process of all the terms from the right going back to the left side. Right. If you look at this, this was negative 1. The inverse of negative 1 is going to be plus 1. Where you were subtracting 1, you are now adding 1. Okay. So if I subtract 1, the reverse to that becomes plus 1. Good. Right. Now, then I'll come to the next parameter, which is positive 2. 2 is multiplying where there is x. So the reverse process of multiplication is division. So it means I'm supposed to divide everything by what? By 2. So the inverse of 2x minus 1 is x plus 1 all over 2. Right. Now, this was quite a process, but there is a shortcut that we can use to get the inverse of a function. Whenever you're asked to get the inverse of a function, there are some basic steps that you are supposed to follow. Right. Now, let's look at these steps that you are supposed to follow. Steps follow when determining the inverse. Okay. Now, the first step, step number 1, we say interchange the variables. Interchange the variables. What does that mean, to interchange variables? It means where there is x, you put y. Where there is y, you put x. Then it means variables are switching position. Where there was x, there is now y. Where there was y, there is x. That's what I mean when I'm saying interchange variables. After interchanging variables, the second step is to make y subject of the formula. Okay. Make y subject of the formula. Those are the basic steps that you are supposed to follow when you are coming up with the inverse of a function. The last one, the third one, it's optional. Some examiners, they are not interested in that. Some, they are interested. So I'll just say, if necessary, replace y with f inverse. Okay, let me try to follow these steps and recalculate the inverse of a function using the illustration that I gave you there. Right, so let's just say example number 1, determine the inverse of f of x equal to 2x minus 1. Determine the inverse of this function. Okay, now how do I get the inverse? I'll come and say this is y equal to 2x minus a 1. Right. The first step is to interchange variables. So I'll say where there is y, there is now x. Where there is x, there is now y. I've interchanged my variables. Now, make y subject. That is the next step. Making y subject, it means I can transpose -1. This becomes x plus a 1 equal to 2y. Divide both sides by 2. That cancels. It means x plus 1 over 2 is equal to what? Y. So y is equal to x plus 1 all over 2, which is basically the same answer that I got when I gave you the illustration there. Okay, now, where necessary, you can also replace y with what? F inverse. So you come and say, therefore, F inverse is equal to x plus x plus a 1, all over 2. Okay, that will be your F inverse. Okay, let me give you more and more examples so that you can familiarize yourself with this method of getting the inverse of a function algebraically. Okay, right. Now let's look at example number 2. Let's look at our second example. Okay, example number 2. Example 2. Right. Determine F inverse given that f of x is equal to 1 over 3x minus 2, something like that. Okay, I'm trying to get my F inverse, right? F inverse. Now look at this. I'm going to say this is y equal to 1 over 3 x minus a 2. First step, we said what? Interchange variables. Where there is y, I'll put x. Where there is x, I'll put y minus 2. Now, make y subject. I'll transpose -2. This will be x plus a 2 equal to 1 over 3 y, something like that. Since 3 is dividing where y is, I'll multiply throughout with an LCM. This will be 3x plus a 2 equal to a third times a 3, my LCM. Simplify. This will be what? 3x plus 6 equal to y. Therefore, the inverse of f of x is y equal to 3x plus a 6. That is my F inverse. I can also present it as F inverse is equal to 3x plus a 6. That is the inverse of a function. Okay, let me give you next illustration. Now, if you look at the first two illustrations, I was only looking at what? Linear functions. But does it mean that every time you can only get the inverse of a linear function? And the answer is no. I can actually get the inverse of any function that you can think of. Right. Now, let's look at this expression. Determine F inverse given that what? F of x is a hyperbolic function. Right. Look at this. 2 all over x plus a 1 minus a 3. And someone wants you to get the inverse of this expression. Not a problem. This should not give us a challenge. Same thing, same process. Y is equal to 2 all over x plus a 1 minus a 3. First step, interchange variables. Where there's y, there's now x. Where there's x, there's now y minus a 3. That is the first step. Interchanging variables, right? Allow me to write it for those that are not interchange variables. After that, after interchanging variables, I can now make y subject. Now, how do I make y subject? Transpose that. That would be x plus a 3 equal to 2 all over y plus a 1, something like that. Remember, I'm now making y subject. Make y subject. Right. Now, how do I make y subject? I can join that to come up with one term. Transpose or invert both sides. This would be 1 all over x plus a 3 equal to y plus 1 all over 2. We are making y subject. The next thing is to multiply both sides by 2. Right? If you look at that expression closely, you realize that I'm trying to make y subject. And for me to make y subject, I'll get rid of that denominator which joins the two terms. So it means this is 1 over x plus a 3 equal to y plus a 1 all over 2. Right. This will be 2 all over x plus a 3 equal to y plus a 1. Okay. I cross multiplied 2 times that, then cleared off that denominator. Now you can transpose 1. This would be what? 2 all over x plus a 3 minus a 1 equal to y. So my y is equal to 2 all over x plus a 3 minus a 1. There you go. This is the inverse of that expression. Now let's look at the second example there, which is example number 4, just determining the inverse of a function. If you look at this section, it's a very, very important section in the sense that in any grade 12 paper, they will definitely test you on the inverse of functions. So it's a must know, right? Now, the next example that I'll give you there is, given that I'm trying to now tap into something close to your examiner's way of thinking, given that f of x is equal to, let me take an exponential function, say 2 to the power of x, something like that. Then they are saying determine the inverse of this expression. Okay, if you want, I can say minus a 1. Still, it's okay. Right, now I'm trying to get the inverse of this. Determine f inverse, something like that. Okay, the first step is to interchange variables. This is 2 to the power of x minus a 1. Interchange variables. Where there's y, there's x. Where there's x, you are now replacing with y minus 1. The next step, as usual, make y subject. I'm going to take that over. It becomes x plus 1 equal to 2 to the power of y, something like that. After that, what am I going to do? I'm trying to make y subject. How do I make y subject? Look at that. Y is an exponent. And since y is an exponent, it means I'm supposed to convert this. I'm now using definition of a logarithm. I'm now converting from exponential to logarithmic form. Look at this. All this is now the number. This is my logarithm, and that is the base. We did this activity. I'm now converting from logarithmic form to from exponential form to logarithmic form. So this is going to be y equal to log what? Of the number. The number is in bracket there, which is x plus 1. Please make sure that you state that bracket. If that bracket is not there, it will mean a totally different arrangement. Okay, and what is your base? Your base is 2. So this is your f inverse. So f inverse is equal to log x plus a 1 base 2, something like that. That's how you get the inverse of such an expression. Okay, right. I'm also going to invert to get the inverse. This was an exponential expression. Its inverse, we said it's a logarithmic function. Remember when we were looking at converting from log form in the previous lesson, converting from logarithmic form to exponential form to logarithmic form. And we said in a logarithmic form and an exponential form, they share a very, very strong bond in such a way that a logarithmic form is an inverse of an a logarithmic form is an inverse of an exponential form, and an inverse of an exponential form is a logarithmic form. So if I'm given an expression like 2 to the power of x minus 1, that's exponential. Automatically, before I even start getting the inverse, I know that the inverse is going to be logarithmic. Okay, right. Let me just give you 1 or 2 last examples. Then you guys will be finished with a lot of activities. Okay, right. Now let me do another example there. Right. Given that f of x is equal to log x base of 5, determine the inverse. Determine the inverse. Determine the inverse of f of x. I'm simply going to say y is equal to log x base 5. Interchange variables. Where there is x, you put y. Where there's that, you put where there's x, you put y. Where there's y, you put x. From there, I'm going to convert. Remember, I'm trying to make y subject. I've interchanged variables. I'm now trying to make y subject. But how do I make y subject? I'm going to convert. I'm going to convert from logarithmic form to exponential form. Okay, right. Let's look at this. Let me give you this example. That was example number 5. That example, it says, given that what? F of x is equal to log x base 5, determine f inverse. And I'm saying this is now y equal to log x base 5, something like that. I'm trying to get the inverse of this expression. How do I get the inverse of this? Very simple. There are 3 basic steps. Interchange variables, make y subject. Always. First interchange, this would be x log y base 5. But if you look at this closely, you realize that this part, that part is supposed to be subject. How do I make y subject in that case? For me to make y subject, simple, I have to convert from logarithmic form to exponential form, which was your first activity when we were saying convert from logarithm to exponential to logarithmic, using the definition of a logarithm. Remember, from the definition of a logarithm, you were saying what? If y is equal to log x base a, this implies what? X is equal to a to the power of y. That's what we did when we're looking at that. So I'm converting from this, which is logarithmic, to that which is exponential. Right. Now let's look at this. Let's convert this expression. You can see that y is the number. This is going to be the exponent, and that is going to be the base. So it means this is going to be the number equal to what? The base, which is 5, the exponent, which is x. Look at this. The expression which comes out is exponential. The inverse of a logarithmic form is an exponential function. So I'll come and say f inverse is going to be equal to 5 to the power of what? X, something like that. We can look at almost all your functions. You'll be approaching it basically the same same way. I'm trying to give you as many examples as possible so that when you get into the activity, it's just a smooth sailing. Right, now let's just look at one last one. I'm trying to draw as close as possible to examiner type of questioning techniques. So I'll come and say, let's just look at the inverse of what do you call that one? A quadratic expression, right? Given that g of x for a change is what? G of x is equal to x. Let me just say x squared, something like that. Right. Now, if you look at this, question says determine f inverse. Good. Right. How do I get f inverse? Same thing, y is equal to x squared. First things first, interchange variables. This becomes x, that becomes y squared. The next thing, I'm trying to make y subject. Make y subject, I'm trying to get rid of the square, so you get the square root of both sides. Square root of x, square root of y squared. So it means this is square root of x equal to y. So y is equal to the plus or minus x. But grade 12s, listen, whenever you are faced with such an expression, or when you're getting the inverse of a quadratic expression like in this manner, please put a restriction. Remember, this expression does not hold for all values of x, because x is under the square root sign, and there's always a restriction which comes with the square root sign. And that restriction says what? X should never be negative. So I'm going to come and say, provided that x is greater or equal to 0, something like that. That is the inverse of a function. Okay, that is the inverse of a function. Like, let me just give you questions here. Let me just quickly give you questions here. Then you can attempt that activity, applying this knowledge. Look at this activity. Look at this activity. I'll give you more and more problems on EduBlush platform. If you follow us, you get more and more questioning techniques there. But for starters, just quickly go through these ones. Determine the inverse of the following. The inverse of the following function. Right. The first one, I've got something like this. F of x is equal to 3x minus a 1. Right. The second one, call it B. This is g of x equal to 3 to the power of x. C, look at this one. Look at this one. It's f of x equal to log x base of a 3. Then D, you can also attempt this one. F of x is equal to 2 to the power of x plus a 1. Then E, you can also attempt this one. F of x is equal to 2 all over x minus 1 plus a 1, which is hyperbolic. Good. DE, I'm sure I'm on F. You can also get the inverse of g of x, and your g of x is in the form log what? X minus a 1, and the base is what? 2. Then G is just what? Last one, which is f of x is equal to negative x squared plus a 1. Okay, grade 12, I'm sure I've tried to give you basic information surrounding the inverse of a function. Attempt that activity and follow us on EduBlush and get more and more questions, and if you expose yourself the more, yourself the more, you'll be grounded on this one. But trust you me, check any question paper, you realize that there is no paper one question that comes without testing you on the inverse of a function. So it's a must understand section. I hope and pray you find this information very helpful, and share it with your classmates and your friends that are also preparing for your grade 12. Thank you so much. My name is Makore. It was a pleasure being with you under this section. The next section, I'm going to be looking at getting the inverse of a function, but graphically. Remember, I only looked at one method, which was just algebraically. Now I'm going to tap into the graphical way of doing things. Thank you so much. Let's meet in lesson 5 under functions and graphs.